Hi everyone, this is the video in lieu of class on Friday, December 2nd. Just a quick note about where we left off last in Chapter 10. I did cover Chapter 10, Section 1, and this homework assignment was due before we took Exam 3 this past Wednesday. I'll make sure to ask the class if anyone has any questions on 10.1 when we meet again next, which I believe, if I'm looking at my calendar, is going to be Monday, December 5th, will be our next in-class meeting. So if you have any questions about Section 10.1, that'll be the day to ask those questions. But today, I'd like to cover Section 10.2, which is addition and subtraction involving radical expressions. Sorry, that's kind of a long title here. The actual section length is very short. It's only 2 pages. So the textbook has plenty of good examples to try out. But let's just go ahead and take the most simplest case that you can find. It would be something if you saw this. Okay, you have 6 times the square root of 2 plus 5 times the square root of 2. All right, when you're adding radical expressions, so long as what's under the radical is the same in both expressions, you're then able to add the coefficients or whatever else is outside of the radical symbol. So you can view something like this, 6 times the square root of 2 plus 5 times the square root of 2. That is just like seeing something like 6x plus 5x. And we know what the solution for that is. It's 11x. Well, in our case, we're just not working with a variable x. We're working with radicals. So you can kind of treat radicals like they're variables. So the solution here, if I wanted to combine 6 square root of 2 plus 5 square root of 2, I could basically, what I'm thinking in my head is I'm going 6 plus 5, and then that's all going to be times the square root of 2, which is the same thing as 11 square root of 2. So I hope this comparison makes these problems, a little bit easier. Another example, if the radicals are all the same, let's say we had 9 square root of 3 plus 3 square root of 3 minus 18 square root of 3. Again, if we treat square root of 3 like a variable, this is kind of like seeing, let's say, 9y plus 3y minus 18y. So we know what we can do is we're just going to go ahead and do that addition and subtraction of those coefficients, and we end up getting negative 6y. Well, that's exactly what we're going to do here. When I do the operations, I do 9 plus 3, and then I subtract 18, I'm going to get negative 6, and then instead of having a variable, I just have the radical. All right, so it's very easy to combine radical expressions. What's going to get a little bit more difficult with these problems is if you see something like this. What if I gave you 2 times the square root of 50 minus 5 times the square root of 32? Big difference now in this example as opposed to the other ones. My radical isn't the same, so I can't treat the square root of 50 and the square root of 32 like the same variable. So what you have to do in this situation is simplify the radical expression such that you get each term in this expression to have the same number underneath the radical, or number and variable. But in this case, we're just dealing with numbers. So if you remember, this is, again, a section 10.1 thing. I could break up radicals like this. I'll give you the example of, remember, a times b underneath the radical is the same thing as the square root of a times the square root of b. So what we try to do with these larger numbers like 50 and 32, we want to try to pull out perfect squares. So for the square root of 50, I would split that into the square root of 25 times the square root of 2. And then for 32, I could do the square root of 16 times the square root of 2. So we know that 2 times the square root of 25, square root of 25 being 5, is going to be 2 times 5. We get 10 square root of 2. And then this is square root of 16, which we know to be 4. So negative 5 times 4 is going to be minus 20 square root of 2. And then now on this line, we have two terms with the same radical. This will now allow us to combine them just like we did this example up here. So 10 minus 20 is going to give me negative 10, and then the radical is square root of 2. So if you get a problem where you're doing addition and subtraction and you're dealing with square roots that are different, go ahead and simplify them down until you can't take the square root of something, and then you're going to end up in these problems having some square root that is the same, and then you'll be able to combine. So far we've only looked at numbers, which I think they're pretty straightforward. Now we're going to start to look at things like this. Let me give you an example. We have 3 times the square root of 12x cubed minus 2x times the square root of 3x. Okay, now we have some variables. Not a big deal. Again, we're going to go the same process as we did this previous problem. We don't have the same radicals here, so we can't combine immediately. But what we are going to do is try to simplify the radicals as best we can. So I'm going to look at this square root of 12x cubed. Okay, I'm going to leave this 3 out here. Then I'm going to multiply it by, I'm going to split the 12 up into the square root of 4 times the square root of 3. So that's separated the 12. And then for the x cubed, I can make that the square root of x squared and the square root of x. All right, so I split that one up. This second term, 2x times the square root of 3x, I can't simplify the square root of 3x anymore, so I won't do anything with that. But if I look over here, I could go ahead and see that the square root of 4 is a perfect square, and then I could take the square root of x squared and get x. So we're going to have 3 times the square root of 4, which is 3 times 2. So we're going to have 6. And then the square root of x squared is x. And then if you remember from 10.1, whatever's left over just goes back in the radical. Now you can see, now that we have the same exact radical expression. So we can treat that like it's its own variable. So what am I doing in my head when I'm trying to combine these two terms? I'm thinking to myself, since the radical is the same, the square root of 3x, I just have to go ahead and perform that operation on whatever is out front of that square root. So 6x minus 2x is going to give me a 4x times the square root of 3x. And we're going to do a couple more examples just so you have plenty to work off of. All right, so I'm looking at this one blind. I'm going to do y times the square root of 28y plus 7 times the square root of 63y cubed. All right, so both of these square roots can be simplified, so let's just have at it. So I'm going to leave this y out front. So for 28, I'm going to split that up into the square root of 4 times the square root of 7 times, now I have a square root of y, I really can't do anything much with that. Now I move over to this next one. I'm going to have 7. Sorry, I actually had my phone ring and I had to answer it, so all right. The first term we took care of it, we figured out the perfect squares. Now for this one, we have the square root of 63y cubed. I'm going to change that into the square root of 9 times the square root of 7. And then for y cubed, I can make that the square root of y squared times the square root of y. Okay, let's go ahead and calculate all these perfect squares. So this first term is going to turn into a 2y times the square root of 7y. And then this second one, I'm going to be able to evaluate this and this. So square root of 9 is 3, so 7 times 3 is going to be 21. Square root of y squared is y, and then I have that square root of 7y. So in these problems, once you simplify those radical expressions, you should end up with the same radical expression so that you can combine. So again, what am I doing in this problem? I see that I have the square root of 7y, and then I'm just going to go ahead and add the terms and coefficients in front of that square root, pretending the square root of 7y is like a variable. So then I end up getting 23y times the square root of 7y as my answer. All right, let's do one more. I'm going to do one more with 3 terms. So we're going to have, let's see, 2 times the square root of 27a to the 5th minus 4a, the square root of 12a cubed plus a squared times the square root of 75a. All right, so let's see what we can do. At this point, hopefully we're pretty good at breaking these up. So when I break this first term up, it's going to be 2 times the square root of 9 times the square root of 3 times the square root of a to the 4th times the square root of a. For this second one, we're going to have a 4a out front, and I'm going to break this up into the square root of 4 times the square root of 3 times the square root of a cubed, or I'm sorry, this will be a squared times the square root of a. And then the last one, we'll have the square root of 25 times the square root of 3 times the square root of a. All right, so I've broken up all of these radicals. Now I'm going to go ahead and evaluate all the ones that are perfect squares, so I'm just going to mark them so you can see what's going on with that. So for this first one, I'm going to have 2 times the square root of 9, so that's 2 times 3, so that's 6, and then the square root of a to the 4th is a squared. And then the radical that's left over is the square root of 3a. So hopefully I'm going to see some square root of 3a's when I finish the rest of the terms. So we'll have, all right, minus. We have the square root of 4 is 2, so we're going to have 4 times 2 is 8. And then the square root of a squared is a, but we already have an a out front, so a times a is a squared. And then what's left over is the square root of 3a. And then this last one we have plus, we have the square root of 25, which is 5, and the a squared is already there, and then we have 3a. Another thing you'll notice in this problem, and it was the same in the previous problem, whatever variables you have out front also have to be the same in order for you to combine them. So not only do we have the same variable out front with coefficients, we also have the same variable and coefficient underneath the radical. So now in my head what I'm doing is I'm combining 6a squared minus 8a squared plus 5a squared, and that's all going to be times the square root of 3a. So I can easily combine these. It's going to be 6 minus 8, which is negative 2. Negative 2 plus 5 is going to be 3a squared times the square root of 3a. All right, so that is going to be the end of this section. All right, so this homework is going to be homework number 1 for the final exam. All right, we only have 3 exams in the class and they're done. So now any homeworks that I collect from now on will be points added on to the final exam. So let's go ahead and give you your assignment. This is section 10.2, and it's on pages 476 to 477. What I'll do for those folks who need to take pictures of my textbook, I'll post those pictures actually right here in this note. So when you go back to this, you're going to see below here where it's blank, I'm going to go ahead and paste in pictures of the problems. That way you have them, right at your disposal right here within the notes. All right, so we're going to do all the odds. I'm just trying to see where I want to start. All right, let's start at 21. These go rather fast, but I'm going to do 21 through 33, and then 51 through 59, and again all odd. So if you're able to do that problem set, I think you'll be good to go. So just feel free to go through these examples, but that's it. So this is going to be due the next time we meet, which is going to be Monday, December 5th. Okay, and this is homework number 1. All right, everyone have a great day, weekend, and I will see you Monday, December 5th.